So in this case, we want to identify our vertical asymptotes, right? So a lot of people automatically just jump and assume that, well, vertical asymptotes are all of our discontinuities. But remember what we talked about last class period. There's asymptotes, and then there's wholes, correct? Yes? So be careful on just saying the vertical asymptotes are when the denominator equals 0. Because if you guys were to go ahead and do that, you would add 9. You could say x squared equals 9, square root, x equals plus or minus 3. So you could say that the vertical asymptote occurs at positive 3 and negative 3. But guess what? That's not the case. Because remember, whenever we're dealing with discontinuities, we need to check, are they removable or non-removable? Removable discontinuities are wholes. Non-removable discontinuities are asymptotes. So to determine if it's removable or not removable, I simplify by factoring my numerator, and I simplify by factoring my denominator. Now what you guys can see is x minus 3 is removable. So therefore, that is my whole. Whereas x plus 3 is my asymptote. So if I just set my asymptote to 3, x equals negative 3 is my only asymptote. Whereas x equals 3 is still a discontinuity, but it's a whole, not the asymptote. Because again, remember what the question is. What is the vertical asymptotes, right? Not what are the discontinuities. If my question was, what's the discontinuities, then you'd say both of them. And you'd say, that's the whole and that's the asymptote, right? But the question is, what's the vertical asymptote? Horizontal asymptote, we have to use the test. So we look at, again, the numerator, our degree in the denominator is 1. The degree in the denominator is 2. Whenever the degree in the denominator is larger than the degree in the numerator, you can say that the horizontal asymptote is 1 equals 0. Okay, and that's it. So just be careful when they're only asking for asymptotes.